Welcome back to part 2 of your check-in for this week. My internet disconnected when I was talking to you about the problem of the college undergraduates in section 4.3. So I'm going to share my screen and complete that at this time, as well as finish with 4.4. I'm going to share my screen. Remind you of the problem right here. And remind you that what I was saying is that all of my data are in percentages except the number of students. Therefore, I turned the number of students, male and female, into percentages. This book was written before binary identification of gender was a thing, so apologies to those of you out there who may not identify as binary people. So the total number of students, we just add what they give us. And in order to get the percentage of females, we take the number of females enrolled divided by the total. When you do that, as you see on the screen, we get 10,980,000 over 19,053,000, which leaves us with about 57.6% female. And doing the same for male, we have about 42.4% male. You'll notice that the sum of these two percentages is 100% because they're complements of each other and because male and females are non-overlapping groups. So you'll see on the next page, I have the tree diagram for you. And I have the percentages listed. Once again, if you need the PDF, we can provide that for you. But this first section is probability of a male without aid. So male, 0.424, with no aid, 0.394. Male and no aid multiply, that's 0.167 or about 16.7%. Now, B is something else that you'll encounter a lot of in this section, which is conditional probability. And B says the probability that the student is a male given that the student has aid. Given that is a dead giveaway for a conditional probability statement. So the given that is the condition after the line. So you're looking for a male, but you're not looking in the entire group because you're given that the student has aid. So what given that does is it serves like a big set of binoculars. It narrows your focus and it expands what you're looking at. So we're narrowing our focus to the students who have aid, and we want the males. So in this case, what we do is we say, let's find the males who have aid. That's going to be 0.424. And we want them to have aid. So it's going to be 0.606. And we're going to divide that by all the people who have aid. So yes, the males who have aid plus the females, 0.576 times 0.652. And when you put that in your calculator, you end up with about 40.6%. Now part C relates back to that mutually exclusive idea again. We want to find the probability that the person is female or they have aid. So this could be a female, regardless of whether they have aid or not, or somebody who has aid, whether they're female or male. So we have the probability of being female plus the probability of having aid minus the probability of having female, and I should have said federal aid. This should be female and federal aid. So this is federal aid. So here I have to multiply by, to get female, that's not hard, that's 0.576. Here we're looking for federal aid. So 0.424, that's the males. 0.606 means they have aid. And if you look carefully, I have another set of bunches, federal 0.448. Okay, and that's where that came from. Plus the females, 0.576, 0.652, 0.504. But this term, with 3 terms in it, cancels. And what I end up with is, it should be 0.691. It got cut off, but it's 69.1%, okay? One more thing about this section, and we'll be done, this lesson rather, is you're going to be doing also counting rules. Sometimes things get too complicated for us to do a tree or whatever. So we have counting rules that help us. And I just picked a problem here to illustrate that. So the problem goes like this. The Hawaiian alphabet consists of 7 consonants and 5 vowels. How many 3-letter words are possible if there are never 2 consonants together and if a word must always end with a vowel? So we have a 3-letter word here. We know the last letter is always a vowel, but we don't know about the first 2 letters. Now we might have CC, except there's never 2 consonants together, so I left that one out. So we could have a consonant, a vowel, and a vowel. We could have a vowel, and a vowel. Or we could have a vowel, a consonant, and a vowel. And then we break down each scenario. So there are 7 consonants, 5 vowels, and 5 vowels. Doesn't say we can't repeat the vowels. So all of these stay the same. This is basic counting principle, fundamental counting here. I do this 3 separate times, and I get 475 outcomes. Now, I know this has been kind of a long video, but I hope that you'll go through it and return to it whenever you can, and maybe go through some of these problems again on your homework. But I hope it's been helpful to you. I hope you stay safe and be healthy, everyone. And please message us if you need help. Hopefully we'll speak to you very soon, and I'll have another video for you next week. Take care, and Lord willing, I'll be back very soon. Bye for now.